Hey everybody, I'm Chris Callahan with UVM Extension, Agricultural Engineering. Andy Chamberlin, who works with me, is going to also be speaking a little bit later. It's great to be with you all, and thanks Heather and Mary for including us in this and making this a multi-state effort. This is a great topic, one I spend a lot of time on, and always enjoy talking about. Poor Andy can tell you, he's somebody who gets locked in a car with me for 6-hour trips, and he knows I can talk about humidity for that at least that long. I won't do that tonight. So we are going to cover the following. I want to talk a little bit about humidity and condensation. This is going to be a little bit of middle school or maybe high school science review. So I know many of you have been just dying to get back into high school science. So we're going to go there just for a little bit because it's actually pretty important to where we go in terms of fixes. I'm going to talk a little bit about maintaining high humidity safely, and also for anybody who's, for example, storing alliums, onions, garlic through the winter. We can also talk about maintaining low humidity if that's of interest to you. I'm going to talk a little bit about troubleshooting condensation for all the reasons that Mary pointed out and others. And then Andy's going to talk about some of the work we've been doing looking at best practices for building coolers. So construction techniques and materials, particularly with an eye towards the expectation that in these coolers, we often want high humidity. And as a result, we can expect condensation. And because of all that, we know we need to clean them and sanitize them. So thinking about some of the best practices, again, that we've been able to compile and frankly learned through lots of grower construction projects being part of that. And I should say just real quick, we work closely, Andy and I and Hans Estrin, we work closely on a number of different construction projects around coolers and post-harvest wash pack areas. If you have questions after this session, please just reach out. I'll give the contact information at the end of the presentation. We'll have some time for Q&A. Okay, what is humidity? If anybody feels like exercising their fingers and wants to type some thoughts in the chat box about how you describe humidity, have at it. Go for it. I'd love to hear what you think. The simplest way I think about it is it's the water vapor that's in the air, right? So around us right now, it's fairly humid today. And what that means is the air is carrying a fairly high amount of water vapor. And the air almost always does that unless it's really, really cold or you're somewhere outside the atmosphere of Earth. And so or unless you've dehumidified, right? So the thing we're dealing with here is that water vapor. We're used to thinking about water vapor being what happens when we boil water. So usually that's above 212 degrees Fahrenheit, right? That's the boiling point of water. But it's not 212 degrees Fahrenheit around me right now, but there's water vapor there. And it's kind of this finicky thing because it's happy where it is until it comes up against a cool surface. And then we have problems, at least in terms of condensation. So humidity, we measure it and we carry it around with us in terms of this term relative humidity. And relative humidity is how much water vapor is in the air compared to the maximum that could be in the air. And that depends on temperature. And this figure is trying to show, for example, the amount of water that air that's 68 degrees Fahrenheit can carry compared to the amount of water in 41 degrees air. It's about 3 times. So the warmer air carries more moisture. Thank goodness, because that's what makes weather systems happen. And that's what allows us to get rain when we do get it. So we depend on this. This is critical to life, but it's something we need to be able to manage in storage and in other places. I see a chat, hang on. But I can't see it. So I'm gonna keep going. Here's the key thing. Humidity is vapor, water vapor in air. Humidity is not liquid water. So if we tend to think about, I need high humidity, I'm gonna spray things down with water. We need to break that habit. That's not goodness, generally speaking. There are times when, yes, you can rehydrate things. You want to pay attention to the quality of that water. But we're talking about humidity, which is water vapor in air. We don't see liquid water around us, it's vapor. And that's how we want it to stay. How do we measure it? My caution here is most people will tend to go to like a weather station or home relative humidity sensor. Be really careful there. In coolers, it's low temperature and high humidity. And those sensors are really optimized for room temperature, relatively mid-range humidity. They're not going to do a great job in a cooler. They're going to be inaccurate and they're going to fail. And it's only a matter of time. So what's the option? My gold standard is a sling psychrometer. That's right, a sling psychrometer. It's the thing that's up in the upper right-hand corner here. This is one brand in particular, and it's called a sling psychrometer because you spin it in the air. Don't spin it in the air in your cooler. That's from personal experience. They're glass thermometers, so we don't want to break any glass in the cooler. What I'd recommend is if you go to use one of these, use it next to a fan. Let the fan push the air over the sling psychrometer instead of slinging it. The way these things work is they measure two temperatures. I don't want to get into a whole bunch of detail here, but there's wet bulb and dry bulb temperatures. The wet bulb is the lower temperature that happens when you evaporate moisture off of a moistened wick at the bottom of one of the thermometers. The difference between those temperatures is actually what relative humidity is. Relative humidity is just a made-up calculation that we use. The real thing we're after is that temperature difference. So you can do that manually with a sling psychrometer. It's about $70 from Ben Meadows, which is a forestry supply company. We've also, one of the reasons I got tired of doing sling psychrometer readings in coolers. I did that for a number of years on a project when I was looking at using cheap electronic sensors that weren't working. And it motivated me to actually develop something better, and that's an electronic psychrometer. So it's a relative humidity sensor that uses this sling psychrometer, wet bulb, dry bulb deal, but does it automatically for you. And that's what's on the lower right-hand corner. Those are my two commercialization partners, Bill and Ralph with VECS, and it's called the Do-Right, and that's an electronic psychrometer. Again, I could go on and on about this. Would love to talk with anybody who's struggling knowing their humidity or who have other concerns about it. I'm going to leave it there for now. So why does this matter? Yep.
I'm sorry, can I just interrupt? There was one question in the chat that maybe is important to answer at this point, if you don't mind.
Yep.
What is the difference between humidity and dew point?
Oh, great question. It'll only take about half an hour. No, I'm kidding. So humidity, relative humidity in particular, is, again, it's the amount of water vapor that's in the air compared to the maximum that could be carried by that air at that temperature. Dew point is the temperature at which water will condense. So for a given amount of water vapor in air, there is one temperature at which that water is going to condense out. It's a very important concept for condensation. Because think about it this way. If your wall is at the dew point temperature, what's going to happen?
You're going to get a river down the wall.
Yeah, right. Condensation, right? So if your wall is at the dew point temperature, which is generally lower than the temperature of the air, you're going to condense water out of that air. It can't. The air that's close to that wall cools down and can't hold the moisture anymore. You're making rain. So that's what dew point is. Hopefully that helps. There is another measure of humidity, which is absolute humidity, and that's a measure of the actual mass of water per, so it's pound of water per pound of air. We'll talk a little bit about that later. So why does this matter? Well, one of the reasons it matters is we're talking about fresh produce, and because fresh produce is alive, it's losing moisture to the atmosphere that it's in, and so having high humidity slows that down. So the higher the humidity, the slower the rate that moisture will leave the surface of the produce. Produce can get sick, and sometimes it gets sick because of overly high humidity or overly low humidity, or for other reasons. And this is one thing I want to bring up. We talked, Mary did a wonderful job covering human pathogen concerns, particularly about Listeria monocytogenes. There are other pathogens that love liquid water that have more to do with produce quality than produce safety. And so all of the same motivations that Mary talked about in terms of produce safety, I would say are equally important relative to produce quality. So think about your coolers with an IPM headset on, mindset. You know, what can we do to manage the other pathogens, the plant pathogens that are in there? Fresh produce also breathes, so it's a living thing. There's respiratory metabolism. The cells are continuing to function, and when the cells continue to function, they're giving up they're giving up oxygen and carbon dioxide and water vapor. Water vapor is being produced by the produce. And so that water vapor has to go somewhere. And so we're adding it to the air. So produce becomes a source of humidity in a cooler. So why does condensation happen? We talked about it a little bit because somebody was clever enough to ask me about dew point temperature. Why does condensation happen? We have certain relatively warm, relatively humid air. So this air has a certain amount, has some moisture in it, and it comes into contact with a cold surface, and that or cold air, right? In the case of weather systems, and when that warm, humid air comes into contact with a cool surface, it can't hold the moisture anymore the same way. So it's going to drop out some of that moisture. It's going to rain, and that's what's happening here on this glass of ice water. The dew point of the air is, the glass surface is colder than the dew point of the air. And so it's dropping water out. That does take some time to happen. It's not instantaneous. And the amount of condensation depends on how long this condition exists. And if you get enough condensation, you're going to get dripping water. And as bad as condensation is, dripping water is a bigger deal because it gets further. It can get into your walls. It can get into cracks in the floor. It can drop onto produce. And whether or not you have Listeria monocytogenes, dripping water on produce in storage is not going to lead to good things. So, you know, lots of molds and mildews will love that environment. So it's about a quality issue as much as a produce safety issue. The graph on the right is just to give you a sense of how the top line is 100% relative humidity. And the axis is temperature. And this is just giving you a sense of how relative humidity really is relative. It's relative to temperature, right? And so at a higher temperature, you have more range of water that can be held in the air. The lower temperature you go, as you go lower in temperature, it becomes a much trickier thing to keep moisture in that air. And that's the challenge in coolers. You're really walking a fine line. There's not a big difference between happy humidity and condensation. So it's a trick. So what's the problem with condensation? Mary did a great job telling us about why it's a concern for Listeria monocytogenes. I love this slide, and this echoes a little bit what I think Heather was saying. We want to think about this as another pest. And in this case, what we're talking about is so this is a nice slide from the Produce Safety Alliance. It's the conditions required for bacterial growth. So whether it's Listeria monocytogenes or other bacteria, frankly, any pathogen, these are things that are factors or conditions for their growth and their survival. And so moisture is a big part of that. And so we want to be paying really close attention to where the moisture is. Is it a vapor in the air? That's awesome. Is it liquid water in a pallet bin of beets? That's not so awesome. And we're not just talking about human pathogens. We want to think really with an IPM lens on this and think about produce quality. Okay, I'm gonna get into some fixes, and then you'll get a break hearing me and get to listen to Andy, which I think you'll prefer. Maintaining high humidity safely, some do's and don'ts. We do want to mix and circulate air. And the best way to do this is Paul's cooler you saw the evaporator with a bunch of fans on it. And those do a nice job mixing the air in coolers. Still, there are some corners where air can sit still and get stagnant. And it's important to break that up and make sure we're mixing the whole space because what we're trying to do is prevent big differences in temperature. When we have big differences in temperature, we tend to get condensation. And so we want to mix that space up so that the walls are the same temperature as the air. And that's what fans do. Some people worry about drying out produce. If you're maintaining humidity, you're not going to dry out produce. Air moving is not going to dry out produce if you're maintaining humidity. The other key thing here is adjusting evaporator temperature higher for high humidity conditions. I have another slide on this. The evaporator, remember, is the unit in the room that cools the air. So you have refrigerant running through a heat exchanger. You have air that's pulled through that heat exchanger with fans. Those are set up for a specific temperature on the evaporator. And they're generally set up for relatively low temperatures so that you can remove heat very quickly. That's great in the middle of summer. If you're thinking about winter storage crops, or if you need high humidity, you need to rethink that a little bit and talk with your refrigeration contractor and make sure they're working with you to maintain high humidity. And the way to do it is to have that evaporator temperature be a little bit higher. The way to think about this is the ice water. So instead of having a really, really, really cold glass of water, we want a cool glass of water. Something that's still going to cool the air, but not take out as much humidity. Sealing the cooler envelope is really important, particularly because oftentimes the water vapor that's being added to the air is actually coming in with outside air. So door seals are super important here, and oftentimes it's just replacing a door sweep or adjusting a door latch on your cooler. Keeping produce between 4 and 6 inches off the floor and off the wall. Why would we bother? It's pretty pricey real estate in a cooler. Why are you telling me to give up to make empty space, Chris? That's a waste of money. Anybody have an idea why we want to do this? I'm not going to be able to see the chat box. So.
Air circulation, I would guess.
Love it. Air circulation is a good reason. Yep, absolutely. Again, avoid some dead zones, areas of dead airflow. What if we do have condensation? What if, as Paul said, his evaporator drain overflows and it's hitting the floor? At least we have some protection from splash up, right? And on the walls, if there's condensation, at least we have some protection from that liquid. So having some space all around, good air circulation and a little bit of margin on dripping. Use storage totes with lids if you need really, really high relative humidity. So oftentimes for storage crops, winter storage crop, potatoes, other root crops, you can do more with a container than you can in the whole cooler. What things to avoid? Go ahead. Sorry.
Oh, sorry, Chris. There was a question that came in the chat box. What temperature would you consider cool? You were talking about a cool glass of water instead of a cold one.
I got a great slide on that. So, and we're talking about the evaporator temperature specifically. So the cooler can run at whatever temperature you need. It's a question of how much below that temperature the evaporator is set for. But I've got a slide that does a better job with it than I could right now without it. So we'll get to that. Thank you for the question. Other questions in chat?
Nope, not right now. Although Hans was trying to make an analogy with magnets, which we might go back to between you and Andy.
Awesome. Looking forward to it, Hans. Things we want to avoid: adding water to the cooler. We don't want to be spraying down floors. We certainly don't want to be spraying down produce. And I know it's challenging if you feel like stuff's drying out. There are better solutions to do this, and it's all the passive stuff. We don't want to cover crops with wet burlap, which I know is sometimes a practice. And we want to be careful wrapping pallets and using liners, because condensation will happen on the plastic once you seal things up. The stuff's alive. It's respiring. It's producing water vapor, and that water vapor is going to hit a cold surface and condense. Also, because produce generates heat, the air around it's going to be warm. And we just learned, we're just reminded that warm air carries more water vapor, and when it hits that cold surface, it's going to rain. So I'm conflicted on wrapping pallets and using liners for that reason. I know why they're being used.
That might be another reason for leaving room between the floor and the wall so that you don't have direct contact with a different temperature, perhaps.
Yep. Yeah, and also for cooling down the bulk storage, the bulk bins, right? Because you got basically a little pocket of heat generation. It produces, even in the cooler, it's generating heat. So again, air circulation and cooling, right?
Chris, we've got a couple people with some questions.
Okay, go for it.
Any thoughts on where to place the circulating fan in the cooler?
Typically in two corners and point towards the empty corner, right? So if you have a cooler that's a rectangle, put one in this corner and one in this corner and point them at the opposite corner. You're just trying to stir the space up, and generally up high.
Okay. And how about bagging carrots for storage after cleaning them?
Yep, it certainly can work, and the thing to remember is perforated bags for a couple reasons. One, so that there is some air exchange.
What?
Responding to him now because your mom's not getting back to me.
Somebody's got to mute. Okay, perforated bags for carrot storage. Two main reasons. One is carrots actually are a fairly significant producer of ethylene, and ethylene is a ripening hormone that actually can become a rotting hormone and a bittering hormone for carrots. And so we want to make sure there's some exchange there so the carrots don't self-bitter, but also because of condensation and humidity.
Okay, and somebody said, we sometimes put a wrung out damp paper towel on top of salad greens inside closed top bins to prevent the top layer from drying out. Is this a safe practice, and will it not lead to increased rot?
Is it a safe practice? Depends on how you're managing that water and that paper towel. The water is now agricultural water, and you need to ensure that it's safe and of adequate sanitary quality. The paper towel has now become a food contact surface, and if you wouldn't eat off of that paper towel, you may want to rethink that practice because it's coming in contact with the greens. Will it lead to rot? I don't know for sure, but I think you'd probably be better off with a bin that has a decent lid. Because it should maintain significantly high humidity in there and protect that top layer from drying. Again, it's important to know what your ambient relative humidity is, and maybe there's something that needs to be done there.
Okay, and it looks like we've got a hand raised. Brian, I'm going to unmute you. Do you have a question, or is this from before? I can't unmute you. Can you unmute yourself?
The question again was just, my question again is still just about whether or not there's a benefit to making sure that the cooler gets dried out.
Yes.
We're new to this. So, so we're trying to get it right from the beginning.
Yep. Yeah. And I do have a little bit on that, but absolutely within any time you're doing a deep clean, it's clean and sanitized, as Mary pointed out. And then I always add, and not just for coolers, but also for equipment and wash pack sheds, also make sure you're providing time for complete drying. I think that's absolutely critical. We've used water now to clean, and we've probably used liquid-based sanitizer to sanitize. So it's important to make sure we're providing great chance to dry. And oftentimes that's adding some or turning on some fans, maybe turning on a space heater, because if we raise the temperature of that room air, it can pick up moisture better. And so we want to possibly heat and ventilate that space a little bit to dry it out.
But the only place it has to go is out the door.
Yep.
So there's a follow-up question to this. Does UV lighting help at all with keeping down the pathogens?
It does. Yeah, there are some cooler systems that actually incorporate UV lighting into the evaporator. So as the air is brought through the evaporator, there's a UV light that is actually treating the air. And they do have there are UV systems with EPA registration as an effective treatment for human pathogens and plant pathogens.
Any chance you could send us a link to that?
Sure, I'll have to dig something up, but yeah.
Okay, I'd appreciate that. Thank you.
Yeah. All right. Troubleshooting condensation. So when we have condensation, it might be helpful to just take a step back and really think through things methodically. And the place I start with is there's water here. I didn't intend for there to be water here. Where is it coming from? And a reasonable place to start is it a leak? Is it just a fitting that needs to be tightened? Is it stormwater? Does this only happen after rainstorms? So is it a building issue that we can address? Or is it actually condensation? And if it is condensation, why is this condensation happening here and now? Did I just bring in a load of apples that are, to use Paul's example, did I bring in a load of apples on a warm day? And is that heat and moisture hitting the cold surface above it, for example, and condensing? Is it stagnant air? Am I mixing the air enough in this cooler to prevent stratification of temperature and humidity? And what can we do? Well, if we see that it's a water source that doesn't need to be there, we can remove that water source. It might be fixing a leak. It might be rerouting drainage that isn't going where it needs to go. We can increase the mixing airflow with fans. One of the things that I've been exploring quite a bit is just simple systems for catching and directing condensation and just using cleanable gutters. So if you have, for example, an outside wash pack area on a day like today, and you're running lots of water, and there's a cold water line that runs right over the doorway where you're carrying produce in and out, that cold water line is a cold glass of water, and it's going to condense water out of the air. So what can we do? Well, in that case, probably not rerun the cold water line, although that's an option. But we could just put a small little piece of gutter underneath that to catch the condensate, and then make sure we're routing that somewhere away from any food contact surfaces, right? So the main concern that we have here is that water that's condensing, hitting food contact surfaces, or frankly, getting inside your building, and leading to structural rot, or other wear on the building. So that's a couple of examples there on the right-hand side. When all else fails, squeegee and towels. Couple examples here, just a traditional squeegee, just pushing some water into a drain. And then Andy and I have been looking into what are known as ultra-sanitary technology, UST cleaning tools. And these tools are specifically designed, Mary made a good point about making sure your cleaning tools are actually cleanable. And these tools are specifically designed to be cleanable. And that green squeegee has no joints in it. It's a solid piece, so it doesn't harbor anything itself. It's a pretty slick design. Somebody asked how cold is cold. So this is a chart from a relatively old reference, but it's a great reference for controlled atmosphere storage and refrigerated storage. Thing to remember here is the coldest point in the room sets the relative humidity. That's because it's setting the dew point. Back to somebody's earlier question, the evaporator is essentially setting the dew point of the room air. And so what this chart is saying is if you control the evaporator temperature so that it's closer, but not at, still lower than, but close to the desired set point, you will automatically, without doing anything, without adding any water to the room, without adding any humidifiers, you will automatically and passively maintain high humidity. This, to me, is the single best way we could be maintaining high humidity in coolers, is by adjusting evaporator temperature. What does that mean? It means that you need to have a conversation with your refrigeration contractor. If you're building a new cooler, it means you're probably going to want a slightly larger evaporator, because you need a larger evaporator to do the cooling job with a higher evaporator temperature. It might also mean you want two modes. You might want a summer mode that's a lower evaporator temperature and a winter storage mode that's a higher evaporator temperature. So the lower temperature will remove heat more quickly. The higher evaporator temperature will maintain high humidity automatically. And that's what I love about this, because you don't have to think about it. Once it's installed, it's going to do it. And it requires an adjustment of the thermal expansion valve. So in a refrigeration system, there's a valve in the system that it's actually setting the refrigerant pressure going into the evaporator. And by setting that pressure, it sets the temperature. And so it's an adjustment of the valve. Anybody wants to dig into this, happy to talk in more detail with you, refrigeration contractor, whoever. CoolBots, by the way, do this somewhat inherently because they were designed as air conditioners, designed for a higher temperature, right? They're designed to maintain a room at 60 degrees. So they have a higher evaporator temperature to begin with. So that's why they're good at maintaining high humidity.
Chris, can I ask a question about the evaporator setting there?
Yep.
If you set it close to the, a little bit higher, and you're trying to maximize the removal of field heat when you bring a big load in, are you decreasing the effectiveness of that unit given that set point?
You reduce the capacity. So if you think about it in terms of BTUs per hour, for a given evaporator, an evaporator of a certain size, if you are using a higher evaporator temperature, it can't remove as much heat per hour.
Right.
And that's why you need to upsize the evaporator a bit.
Right. Or having a smart evaporator that could crank its thermal expansion valve down and then during, when it sees a call for it.
That's right. Yeah. So I'm actually working on a demo of that. Looking to do the install in September for this 2-mode option. So yeah.
Cool.
Andy Chamberlin, you able to unmute?
Hello.
Howdy, go for it.
Hey, good evening, everybody. Hope you're having a good day. I'm Andy Chamberlin. I work closely with Chris Callahan and spend most of my time doing education and research in the pack shed about pack sheds, and coolers are included in that. So here I'll share some resources that are linked below if you didn't catch that already, to other fact sheets and information we have available. So I just want to touch base here on drains and floors. So you can see this picture is from inside of a pack shed, not a cooler specifically, but it shares the same floor actually. And you can see here that it's a concrete floor, which is like the best of the best. It's smooth, it's cleanable. As you can see, it's easy to squeegee, it's easy to sweep, it's easy to hose down, and has an integrated floor drain. Now, floor drains aren't usually required in a cooler because there isn't usually that much liquid water in there, except only for the time that you're doing maybe your annual deep cleaning. So it's nice if you can have one, like the spot drain here on the bottom left corner. But most of the time, coolers don't have them. But if you're building one, you might consider at least putting something in there. While we're talking about floors, there was a comment earlier about wood floors, and that can be a challenge. I know it happens at times when you're building a cooler into existing barns and spaces like that. You can't always have a concrete floor, and it is beneficial to insulate a little bit underneath it. And it is important to treat that plywood with something, whether it be a polyurethane or really would be like a marine grade paint. They make floor grade paints or epoxies as well that might be more durable and hold up well. So that's kind of the downfall, is that it will flake or chip and will require maintenance over time, because you really should protect it from the moisture and humidity in that space.
Thanks for remembering to talk about that. The other thing, there was the point about people have heard that wood cutting boards have antimicrobial benefit. That I've seen information on both sides of that. The place where I land is do what you want with a wooden cutting board in your kitchen. The cooler floor is not a wooden cutting board. it doesn't get the same benefit of frequent drying and cleaning. So I do not tend to think about cooler floors, wooden cooler floors or walls as having antimicrobial properties. It's also pretty specific to wood species, based on the studies I've looked at, and we're not using any of those nice wood species in plywood.
There was a question that just came into the chat box on the same topic. We have a repurposed refrigerated 20-foot shipping container as our cooler. The floor has tracks that are about 1 inch deep. Best way to clean without busting any biofilm?
You want to bust those biofilms. If you're cleaning, clean. So, you know, empty the thing out and go for it. That, you know, that you want to prevent the buildup, accumulation, and sustained existence of biofilms. So that's my take on that. And in terms of how to do that, a good stiff bristled nylon brush would, or a larger size bottle brush would probably do well. Take it easy with pressure washing, because where does the power wash go? All
Right.
over.
Sorry, Chris, I couldn't find my little mic again. Yeah, I'm so glad that question came up, because that is not what I intended to say. That, oh no, if you don't want to break the biofilm breaks and then it contaminates stuff. The goal is not to have a biofilm there. The goal is just to keep things dry, keep things cleaned and sanitized and scrubbed in order to not have the biofilm. It's not to have the biofilm not break. So thank you for asking that great question.
So while we're talking about floors and water, one way to avoid that source of water is with your evaporator drain. So lots of moisture can collect on the floors of coolers, and you want to make sure that your evaporator itself is draining into a dedicated space. I mean, if you don't have the ability to drain it out via plumbing, even down into a bucket so it's collected is a great idea. A lot of commercial units like this have a drain fitting on the bottom, so it's not that hard to connect something up. I've seen some CoolBots, even the large units have a hose fitting on the back to do just the same thing. Otherwise, you get dripping like this bottom right corner. And you want to make sure that the CoolBot is installed tilted back a little bit so it does drain out and away, not down into your cooler. And if you're running a CoolBot unit that doesn't have a built-in drain, I've seen where some people have rigged up just like a funnel to a tube down into a bucket, and that worked fine too. It was a great way to contain that moisture. So thinking about where that is going will really contribute to, especially if you have an exposed floor like we were talking about. Now there's a lot of different insulation options, and really these are going to vary based on your situation and your budget. So if you're building a cooler in a blank space, you've got a lot of room, there are kits available. So you can essentially put these foam blocks together and build a cooler straight up. If you're trying to shoehorn it into an old barn, then this is where you might be DIYing something and need to make insulation fit. So there's various types out there. You get the blue polystyrene. It's called blue board. It's also pink. I've seen it in green. It really just depends on the brand. Then there's polyiso, and that's generally foil backed. It's a white, your traditional styrofoam, and it's foil backed. Then there's also bat material. So stone wool or rock wool bats is really great because moisture doesn't like to live on it. It actually beads off of it. It's also fireproof, so you can literally hold a torch to it and it will not light. It's made from volcanic rock and steel slag, so it's a pretty durable stuff, sound absorbent. I'm a big fan of that. We generally don't recommend pink fiberglass insulation or cellulose due to their exposure to this moisture, especially in coolers and pack sheds in general. So even though they're the cheaper materials, it's worth spending a little bit more on a nicer material. What we don't have pictured, but you see on the chart here is spray foam. There's two kinds of that: open-celled spray foam and closed-celled sprayed foam. Closed cell, you need less of it because it has such a higher R value, And that also helps as your vapor barrier as well, so you don't need that plastic sheet over your framing. So that's another perk, but you can't install that yourself, and you can install these foam board sheets or these rock wool bats. So there's a few different options there. Again, we outline this at the Cooler Walls blog post linked below. Like I started to say, there's these panels that you can get for your cooler. So metal insulated panels called MIPS, or these SIPs, which are structurally insulated panels. You can get them laminated between OSB or plywood. They can be load bearing. So these are originally designed for like post and beam structures, actually. So it's made for really easy installation of wall systems. So if you're building new, this is something to consider, and you can get them ordered with like electrical tracks and everything already pre-cut, so to speak, because it's hard to add that stuff later. One thing to think about is smooth and cleanable surfaces, so you don't have this bare plywood exposed in these high moisture environments. And that brings us to the next slide, which is some options for these smooth and cleanable materials. So earlier I heard somebody had FRP, or fiber reinforced plastic. That's also known as dairy board. It's pretty commonly used. I think a lot of people are familiar with it. It's often textured a little bit. It's pretty strong. So you can take a plastic bristled brush to that and not worry about scratching it. I mean, shy away from any wire brushes or anything super aggressive, but it's made to be clean, so it can take that quite a bit. I'm a big fan of truss core, and it's a corrugated plastic, much like a twin-walled polycarbonate on some greenhouses. That would also work well. This is white, it's easy to clean, and it installs really easy. So the FRP, you have to glue it up onto an existing wall of plywood, of sheetrock, which was not good for a cooler, but it needs to be glued up and installed very securely, or they can peel and delaminate and not work well. But truss core installs quicker because you can go right on top of furring strips or your stud bays, so you don't need the plywood backer. So you save a little bit of cost and materials there, but you pay for it in the plastic. I think that's a good trade-off based on the labor savings that it's going to take if you're installing this yourself. I've seen some farms install this both in their pack sheds and in their coolers, and they like it a lot. Another option is metal roofing. It can be magnetic, which is a plus. It's a little bit more durable than plastic, a little bit harder to work with just because it is sheet metal. It's harder to cut. It's sharper. It's a little bit heavier, but one of the cheaper options and more durable. So that's also a plus. And then kind of an in-between is ribcore. So it looks like the metal roofing, a little bit wider than the truss core panels. Perfect for a ceiling application because it's not quite as strong, but it covers further. So there's some options available there. And back to you, Chris.
Thanks, Andy. I did, we were pasting in short links to some of those resources as we went as well. So hopefully folks can catch up. Question from Shauna, do you have to worry about moisture building up between one of these coverings and what is behind it? Yeah, wall construction details are, they can be quite tricky. And the key thing, three key things from my perspective, happy to hear what Andy's thinking as well. Need to have a way for it. Well, there needs to be a vapor barrier somewhere. You don't want the moisture from inside the cooler migrating into the wall. And if you think about most prefab coolers, there's moisture barriers on both sides, right? And so both inside and outside. So having a moisture barrier, typically it's behind that finished surface. So the moisture is being blocked from getting into wood framing, for example. Andy mentioned furring strips for mounting, for example, the truss core or the metal roofing. And those would tend to be on top of the vapor barrier. And then the finished surface would go on top of that. You can also, some of these finished surfaces can be put right on studs. So you have a studs, vapor barrier, and then finished surface. The finished surface, if it's well sealed and caulked, can actually be a vapor barrier and prevent the moisture from getting into the wall construction. The thing you need to plan for is having a problem with your sealing. Even with the best of intentions, you're not going to seal every space. So typically, wall constructions are designed so that they can be ventilated to some degree, just natural ventilation. So, short answer, Shauna, yes, you want to plan for moisture getting behind your finished surface, and that's typically what a vapor barrier does behind it. Just to wrap up, some of the key points that I would like to leave everybody with is really shy away from adding water into coolers. There are better ways to do this, and we're here to help you find those solutions. Some of those better ways are passive relative humidity control by using evaporator temperature, knowing your relative humidity. And so if you're not currently measuring relative humidity, I'd encourage you to get a sling psychrometer. If humidity is important in your life, get a sling psychrometer. And you'll be surprised, I think, how high humidity generally is in coolers. So you really shouldn't necessarily have to add water. Providing air circulation with some small fans, and the easy check on this is go to the corners of your cooler and see if you feel air moving. That's the simple check. There's nothing too fancy about it. We just want to make sure we're mixing up the space. Pay attention to sealing the envelope. So checking the door sweep and the bottom of the sweep on the bottom of the door, checking to make sure the door latches tightly. And building the cooler, assuming that you're going to have some condensation. A lot of things that Andy just talked about. It's basically building a space that is going to have some liquid water in it at some point or need to be cleaned. And then finally, annually, we want to be doing a deep clean, at least annually. And I think if you can do it more frequently, maybe change of season or major changes of season, that'd be fantastic. Clean, sanitize, and don't forget to dry. Those are my thoughts on that. Best way to keep in touch with us?
Can I ask just a question? I had to absent myself to close the stand down.
Yeah.
Did anybody talk about, we had water one year in a cooler, and we have a cool bot, and I discovered it was because algae had built up in the air conditioner, so that I had to unplug the hole. Does anybody add like a couple of drops of bleach or anything like that? Is that effective, in stopping that problem?
So you had the air conditioner drain block up?
Yeah, and so
Yeah.
it came into the cooler then, and I actually had to get a squeegee until I figured out what the heck the problem was.
Yeah, Paul referred to that earlier when talking about his evaporator drains and making sure. I mean, I think it's putting it on a list so that it gets looked at least once a year and cleaned. There are cleaners out there specifically for refrigeration heat exchangers.
Okay.
I've heard mixed experiences with those. They're supposedly you spray them on, you let them sit for 5 minutes, and you hose them down. I've heard mixed stories on that. I think probably back to one of Mary's key points, it's elbow grease.
Yeah.
And planning. Yeah.
Pipe cleaners or gun cleaners, like those kinds of scrubbers that could get into small holes. Bleach is not going to work that well because it's not going to penetrate where it needs to.
It's been
Bottle brushes. Yeah.
decades since I've seen a pipe cleaner. They still make those?
Yeah. Actually, Andy and I have been uncovering all sorts of cool new bottle brushes too.
Okay.
That we'll have a post up soon showing some of those things. But yeah, there's some great new cleaning brushes.
Well, thank you.
Thank you, Steve. Yeah.
I was going to just say one more thing to answer the question about does drying kill listeria? And I'm going to have to watch this whole presentation again because I spent some time looking for information on this. And it looks like generally it doesn't kill it, but having a dry place is where you're going to minimize the risk of listeria being there or being active, right? So if it's wet, it's going to be like, yay, this is where I live. It's wet, it's cold. Keeping things as dry as possible is going to reduce the risk of listeria growing It's not going to grow in a dry environment, but it might not die. So like everything else, you want to minimize risk. You can't like totally eradicate it probably, but you can minimize the risk that it's going to flourish and contaminate your space and your food. Is that helpful?
That's great for me, and it reinforces the need for considering using a sanitizer, because that is our control for many of these human pathogens.
Yes.
Chris, this is Vicki.
Hey, Vicki.
Forever the regulator that I am, I have this conversation with growers of how the produce safety rule addresses flooding the coolers, especially for apple orchard growers. And I'm not sure, I haven't really heard what the produce safety network, how to address that. And whether it's a violation because they won't stop flooding. And I just want to kind of throw that out there. And I don't know if you've spoken with anybody else. I've been in coolers. So anyway, I just want to throw that out there.
Well, if it's reasonably foreseeable that there could be produce contact, what kind of water is that?
Right. But that's right. No, I know
That's
where
my
you're going
take.
with it. Yes. Yeah.
Yeah, it's ag water,
Yeah.
and the floor is now a food contact surface.
Sure.
So your choice as
Right.
as the farm, do you want to treat that water? Do you want to treat that surface as a food contact surface, or do you want to find a better way to manage humidity?
Sure. Have you heard from any other parts of the country how they're addressing that also?
Ignoring.
Yeah.
Yeah,
Okay,
it's a concern. It's a
Right.
concern because it is a wide, a very common practice, flooded floor storage.
Sure.
There has been movement, particularly in the CA apple storage world, toward evaporator temperature control
Right.
using chiller loops instead of traditional refrigeration loops for that
Yes.
very reason. So you're
Right.
maintaining humidity by maintaining the air temperature.
Okay.
Yeah.
All right. I just want to throw that out there.
That's a key question. Thanks, Vicki.
Okay. Thanks, Chris. Great information, everybody.
Cool.
I just want to really thank all 4 of our speakers, Paul, Mary, Chris, and Andy. This has been really great. We planned this to go until 7, hoping that there'd be time for discussion afterwards. So at this point, I guess I would just encourage anybody who has questions to unmute themselves or throw the question in the chat box. This is our opportunity to pick some brains. There's quite a lot of brain power on this call. So let it rip, I guess.